Hi everyone, this is Lava. I welcome you to AI Expert Corner series. Today we have Sudharshan Ravichandiran with us to talk about some of his work at Param AI, and he has also authored a couple of books in the advanced areas of machine learning. So let's get started. Hi Sudarshan, I'm very glad to have you here, and a warm welcome to AI Expert Corner series. You're a data scientist at Param AI, and you also authored a couple of books in the subfields of machine learning, such as reinforcement learning and meta learning. Can you walk us through your journey at Param AI and what got you started on writing books in the specialized areas of machine learning?
Yeah. So Param.ai is basically a AI recruiting platform. So it basically automates and makes the life of recruiters very easy. So what it does is like, let's say when you're hiring for a particular position, you get like hundreds of resume depending on the position. So it's impossible for someone to really go through every resume and identify the potential candidate who are suitable for the job. So what Param does is it understands like which candidate or the birth, like which resumes are very relevant to the job which has been created, and it stack rank all the candidates based on that. Okay. So based on this, we get to know like which profile is very important, which profile we have to look at first, and we can directly assess the candidate and schedule the interviews. It's based on the understanding of the job description. It's based on the resume understanding of all the candidates. So that's how basic stack ranking works in Param.ai. So apart from this, we also have a personalization engine which will understand the activity of the recruiter. Let's say how the recruiter is hiring for this particular position, like what are the candidates who have been interested in, like what set of skills they are looking for, like which educational background or which industry they are hiring the candidates most. So based on lot of parameters, Params understands that this is how a recruiter from this particular company hires for this candidates. Based on this understanding, it will then auto suggest the good candidates according to the mood of the recruiter. So this is what with the work which I've been doing at Param.ai, and I've published two best-selling books. Which is the first book is about reinforcement learning, and the second book is on meta learning. The reason I just wanted to publish a book on reinforcement learning is that at the time of I'm writing the book, there was only one book on reinforcement learning. So I thought since I know the topic well, why can't we publish a book? So I just contacted the publisher, and it went well, and then I published. And the second book is meta learning, and meta learning is it like a really good thing which is about happening in the AI lately. It's about automating, and it's about generalizing building models and learning from small data sets and all. Like it's an evolving field of AI. So, and again, there is literally no books on meta learning. So that's why I started, writing a book on meta learning as well, and it got published.
Okay, great. You have expertise in reinforcement learning and meta learning space, and I see some of the major applications for reinforcement learnings are into self-driving cars and industrial automation. So, do you see the scope of these techniques at your workplace?
So again, in my workplace, it depends on the kind of use case I'm working in. The algorithm, whatever the architecture which I'm using, it depends. It's directly proportional to the use case which I'm working in. So right now, what I'm working on, it's based on a deep neural net architecture and something related to that. And there is really not a scope for reinforcement learning at the currently the work which I'm really involved in. I mean, there is no much of a scope for reinforcement learning right now, because reinforcement learning is still evolving and it's still a long way to go for it. And but again, meta learning is something which is pretty good, and I'm already implementing meta learning algorithms at my work.
Okay. Reinforcement learning is considered as one of the three machine learning paradigms alongside supervised learning and unsupervised learning. So, what are the fundamental differences in terms of training a reinforcement model versus training a supervised or unsupervised model?
See, when you say supervised and unsupervised learning, in supervised learning, basically you have a data set with the good labels, whatever you wanted to, and you train on that, right? Whereas in unsupervised learning, you don't have any labels. You just try to find the patterns in the data set. So this is what the one of the two famous paradigms of machine learning. But what reinforcement learning does is that it learns through the mistakes. Like it just try to do some actions and just get to know whether the action is good or not based on some reward. And it understands that if the reward is high, it understands that what it does is a good action. If the reward is less, then it understands that the action which it just does is not a good action, so it will not do that action again. So it's basically, you can say, reinforcement learning is more of a like a trial and error method where you try some actions, get some reward, check whether the reward is positive or negative, like it is high or low. If it is low, it means that that is not a good action, so you refrain doing that action again. So it's basically how any child, inborn can learn, that's how it is.
Yeah, so what kinds of machine learning algorithms are available to implement reinforcement learning? And does the same techniques, like in the case of supervised or unsupervised learning, we minimize the cost of an objective function by something called back propagation? So does the same techniques works for reinforcement learning to understand the reward system?
Yeah. So when you say reinforcement learning, it has its own set of algorithms like Q learning and TD learning, SARSA. A lot of algorithms are there for reinforcement learning. But the reinforcement learning, which is so popular and like which got so popular these days, is due to the integration of reinforcement learning with deep learning. So that's how people call it as deep reinforcement learning. So let's say there is an algorithm called Q learning. So what happens in deep reinforcement learning is that you just integrate the Q learning with the deep neural network. So that's how it is. So what it learns is that a deep neural network which is trying to learn the Q learning. So and again, so when we say deep neural network, so how it learns again, it learns through the back propagation algorithm.
And how meta learning is different from reinforcement learning?
When we talk about meta learning, so it's about a learning. So whenever we wanted to train any algorithm, like any network, so you need a bunch of data, like huge data points to train a network. But when you talk about meta learning, you don't need such large volume of data points. It learns from very less data points. So how it is learning from a very less data points is that it learns. Let's say you have some n number of tasks. So what a meta learner will, so you call it as meta learner. So what meta learner does is that it learns from all these tasks and try to understand what all these tasks are about and generalize on a new task. Let's say you have some 10 number of tasks, so we'll train the meta learning model on all these 10 tasks. When a new task comes in, it doesn't expect, to provide you a large number of data points. Even if you provide like 5 data points, it leverage the knowledge which the model has learned in the previous 10 tasks on a new task and try to learn from there.
Okay, can you provide an example of where meta learning can be used?
So, okay, you can think of meta learning as transfer learning, like just like an example, but meta learning is not like transfer learning. In transfer learning, what you basically do is you just transfer the weights and you learn from there, right? But in meta learning, you just don't do that. So, what you do is, let's say you're performing an image classification. Let's say you have images from different domains. Let's say you have images from 10 different domains, so you basically train the algorithm to train the model on all these domains and try to understand like how the how it is learning on all these different domains, how it is trying to recognize the images in all these domains. So let's say in all these domains you have a good number of data points. When a new data set comes in, like when you wanted to recognize the image on a new set of domain, so what it does is it leverages the knowledge which has learned in the previous set of tasks, like previous 10 tasks or n number of tasks, and uses that knowledge to detect the, to identify the images or whatever in the new domain, in the new task.
When you say transfer learning, do you mean that you take a model that got trained on some feature rich dataset and use it to transfer the learned weights onto your own dataset, which might be less feature rich? So, is that how it works?
So, like again, transfer learning, it's like you, let's say you have an, let's say you're performing image classification, like for instance. So, let's say there is one popular image data set called ImageNet, which is a collection of like 20 million images or something. So, when you train it on that level of data, your network understands the optimal weights, optimal weights to perform any image classification. So what you do when you wanted to perform an image classification in a new task, let's say you have a, let's say you wanted to perform like whether a image is a car or a bike or which vehicle it is, you don't have to train it from the scratch since you already trained on a huge data set and you already have the good number of weights. So what you basically do, you initialize the network which those obtained weights, and then you start, performing classification on the new task, new data set which you wanted to try on. So you can think of like transfer learning is just transferring of weights from the pre-trained network.
So that will simplify the computation time and the process for training new models, right?
Yeah, that will definitely simplify the computation process and it will minimize the learning time because we are not training it from the scratch. We are just transferring knowledge by using this pre-trained models.
Okay, let's talk about the tools and libraries that you use at Param AI as a data scientist to solve the data science problems.
Okay, so tools, I don't use any specific tools, for instance. So, I mean, I'm just use Python and Jupyter notebooks and maybe PyCharm and IDE, that's all. I mean, not specifically any tools. Maybe I can tell you libraries which I use. So, I use TensorFlow a lot. TensorFlow is my favorite library. And apart from TensorFlow, I use Pandas and Scikit-learn, NumPy.
Okay, how do you train these models in a production environment?
Yeah, so we train all the models on the Google Cloud.
Okay. So how do you compare different models? Like you have a certain model, and how do you know that a particular model is giving accurate results, and how often you should train those models?
Yeah, so there are various metrics, right, to assess the model's performance. So when you train multiple models, definitely, let's say you train some X model with some n number of parameters and with various network layers and all. You take some Y model and you train it with different number of parameters and different architectures. So when you do that, you just try to assess the training accuracy and how the model is generalizing well on the test set. So based on these comparison, you come to a conclusion that which network architecture is good, and you finalize that model. So basically, what you have to keep in mind is like you just wanted to understand how well the model is generalizing. That is how well it is performing on the test data sets.
Okay, what about the team structure at Param AI? How does the work gets distributed when coming up with a machine learning solution?
Yeah, so again, it depends on the use case and the complexity of the works. So based on that, the work will be split across the team. Maybe someone would be working on building a feature engineering and identifying right set of features, and obviously someone would be working on data engineering, pulling the data from the data source and structuring the data, getting into the right format. Someone will be working on the research, like a core of the algorithm, like or building a new algorithm and then writing a code for it. So that's how it works. It depends on the use case and the complexity of the project, but definitely the work would be split across like a data engineering and data cleaning, feature extractions, and model building, something like that.
Okay, how challenging is the interpretability of machine learning models when trying to improve its accuracy? And are there any good techniques for interpreting the results?
Yeah, so yeah, and again, like interpretability in machine learning is always challenging as in like let's say when you train a deep neural net, you never know like you can just you have no idea like how it is exactly extracting, like what sort of feature it is extracting. Let's say you're building a CNN, You never like we can just intuitively that individual layers learns, intermediate layer learns edges and whatnot. It learns to try to recognize the important features of the image, but you never know how exactly, like how exactly and how what are all the features are being computed in each layer. So interpretability is always challenging when it comes to machine learning. But again, like if you're working on a very basic model, let's say a logistic regression, you can easily say that which feature is more important and based on the coefficients. Like you can just give a very quantitative metric that this feature is this feature has this coefficient, so that means this feature is given more importance when building a model. So the system must learn that this is the right feature for building a target, and it has predicted it. So something like that. You basically, when you do any prediction, it's all going to be based on the features. So you can just quantify those features and how it has predicted the target, something like that.
How often would you train your machine learning model, and what are the metrics you would measure to understand your model needs to be trained with more recent or latest data?
Yeah, and again, so it's again, it's completely depends on the what kind of use case I'm working on. So right now, like what we basically do first, we'll make sure that model is well generalizable and it is performing well on a number of test cases. Only if it is very only if it is like well generalizable, it's being pushed to the production, and all the predictions will happen. If it's not, then it won't be pushed to the production itself in the in the first place.
Okay, so how much data in general is needed for training a model?
Mm, See, there isn't any metric or a threshold to say that this is the amount of data we need. So it's like when you have more data points, the system will learn more information, and it can generalize well. When you have less data points, it cannot generalize well. And again, when we say more data points, the data points should also capture all the features, like all the variance in the data. If you have like a million data points, but all the data points have same set of features, and it's no use. Like same set of information, then no use. When you have a million data points with a varying information, then it is very good for the model to generalize. So it's good to say that more number of data points for a better result.
Okay, so in terms of deploying to production, right from gathering the data to deploying. So, do you have a process at Paramay where some automated process that extracts, transforms, and loads into some um, into the Google Cloud engine? So, is it an automated process, or you will have to do it manually?
Yeah, so we have an internal package, and like we have an internal module to do that. Like once everything is done, it's automatically get pushed to the Google Cloud, and the model is deployed and all. So we have automated that process.
Okay, so do you use any of the uh, databases for streaming all of this information, like Apache Spark or something?
Yeah, yeah. So we use Spark and Postgres and all that.
Okay, okay. What do you advise to somebody who is entering into data science field after having close to like 10 plus years of experience, and where do you think they can fit into this career path?
If someone like wanted to shift to data science after having like 10 years of experience, I think someone like they're really enthusiastic and passionate about learning data science or something like that. So if they're really passionate, they just wanted to brush up their skills on linear algebra and calculus and get started with it. So I think it's more easier for someone to have someone who have good knowledge, like good experience, but obviously it takes a lot of time. But again, it's not something doable.
Okay, cool. Thank you, Sudarshan, for your time and sharing your expert views for us on this AI Expert Corner series. It was pleasure hosting you. and we hope to host you again in the future. Thank you.
Yeah, yeah, thank you for having me.